Let's look at question number 5 on the homework. A ball rolls off a desk with a speed of 3 meters per second and lands 0.4 seconds later. There are several parts. How far from the base of the desk does the ball land? How high is the desk? And what is the speed and the angle of the impact on the ground? So obviously this is two entirely separate questions, the speed and the angle of the impact. First, let's break it down into the horizontal and vertical components. For the horizontal components, those are the x values. And for the vertical components, those are the y values. Let's take a look and see what we know. We know that Vx is equal to 3 meters per second. And we also know that time is equal to 0.4 seconds. On the vertical side, we really don't know much. We know that the acceleration is equal to minus 10 meters per second squared. That's actually a lot, because we also know that time is the same for the vertical and the horizontal. Time is 0.4 seconds. On the other side, dx, how far away did it land? That's an unknown. But we do know that dx is equal to velocity times time. So Vx times t. We can substitute in right there, and we know that our Vx was, that should be a parentheses, 3 meters per second times 0.4 seconds, and that ends up being 1.2 meters. So that's the answer to the first question. How far away does it land? Going back to the other side, it says how high is the desk, so we need to know dy. We don't know dy, that's an unknown, but we know that dy for a falling object is 1/2 a times t squared. That's a squared right there. We can substitute in, and for 1/2, we'll substitute a 1/2. For t, we'll substitute in 10 meters per second squared. And for t, we'll substitute our 0.4 seconds squared. When we do that, I know this handwriting is bad, but we end up with 1/2 times 10 is 5 meters per second squared, and 0.4 seconds quantity squared ends up being 0.16 seconds squared. The units are also squared. When we multiply that together, we end up with dy is equal to 0.8. Wow, that's an 8 meters. So that right there is the answer to the second question, how high is the desk? We still need to get the speed of impact, and for that we're going to need to know Vy. How fast did it hit the ground? Well, in the horizontal component, we know its velocity was 3 meters per second, but we don't know the vertical component, but we can get it because for a falling object, we know that velocity is equal to acceleration times time. So that's the velocity of the falling object. So we can substitute in our 10 meters per second squared. That could be minus 10. 2 if we want to look at the negative component of that velocity, and we plug in our time, 0.4 seconds. When we use 10 for our velocity, or for our acceleration rather, due to gravity, it becomes trivial, and we end up with 4 meters per second. Now, this right here is not an answer to any of our questions up the top. It's not the speed of impact, but it is the the vertical speed of impact. So Vy is this direction, 4 meters per second. Vx is this direction, 3 meters per second. So what we really need is to figure out the resultant. So if the ball is going down like this at 4 meters per second, and its horizontal velocity like this is 3 meters per second, then its actual impact will be in that direction, and that direction we can solve for that because we know for a right triangle we can use the Pythagorean Theorem. We know that the square root of Vx squared plus Vy squared is equal to the resultant velocity. That's equal to the square root of 3 squared plus 4 squared, which is equal to the square root of 25, which is equal to 5. Now this has the same units as the original vectors. Those original vectors, the units were meters per second, and so we have ended up answering half of part C, 5 meters per second. To find the angle of impact, we need to first decide which angle we're going to use. So let's look at this angle right here, and this will give us angle from the vertical. We know that the tangent of an angle, theta, is equal to the opposite over the adjacent, and since the opposite over the adjacent is 3 over 4, we know that the angle theta is equal to the inverse tangent, or tan negative 1, of 3 over 4. If we plug that into our calculator, we get 36.86. We'll just call that 37. That is a 3 and that is a 7. 37 degrees from the vertical.